Hi, so in this video we're going to continue looking at the star expressions in function parameters. Now just recall from our discussions prior on unpacking iterables. We can unpack iterables this way. So for example, let's say we want to take A, B, and star C, and we can unpack this tuple over here, let's say 10, 20, A, and B. And so we'll get that A is 10, B is 20, and C will be the list containing the characters A and B, the two strings A and B. So that's how it works with iterables. Now it works the same way with functions, or at least in a very similar way with functions. We can go ahead and define a function, and we'll set up, let's say, the two positional parameters. I can type the star there. And then that last star C, which is going to behave basically in the same way. And we're just going to print A, print B, and print C. So this now basically allows us to call func1 with two or more parameters. If we call func1 with just two parameters, let's say 10 and 20, then we'll see that A was 10, B was 20, and C was just nothing, so it's an empty tuple. And it does return a tuple, not a list. That's the one kind of difference that we have with the iterable unpacking. But it's perfectly fine not to have extra parameters. So these basically are just optional parameters, and we can have as many as we want. So we can in fact call func1 with 10, 20, let's do 1, 2, 3, let's say. And then you'll see that, again, A is 10, B is 20, and then C is the tuple 1, 2, 3. So that's how the star thing works in functions. Now, typically, we don't use C. A very common convention is to use star args. And so here, we would use args as the parameter name. But it works the same way. As you can see, I executed those, and the same results came back. So that's more of a convention than anything else. But if you happen to see star args in functions, that's all it is, right? It just allows us to pack an arbitrary number of variables into, or arguments, into a single tuple that's available inside the function. So how might we use that? Well, let's say that we want to write a function that's going to calculate the average of all the parameters that are passed in. But obviously we want this function to be able to handle an arbitrary number of parameters. So we do that using this star args. In fact, let's go ahead and create this function, and we're not going to have any positional arguments, parameters. We're just going to have that single one called star args. And we're going to initially just print it out to see what happens when we call it. Well, if we call average with nothing, we end up with args being an empty tuple. If we call avg with anything in there, then that 10 and 20 will be inside that args tuple, right? So that's how we're going to recover the values of the arguments that are being used when the function is called. Inside the function, we're just going to look at the values that are inside the tuple called args. So let's go ahead and change that up now, and let's actually do our calculations. So we're going to need to find the count. So the count is just going to be the number of variables, right? The number of arguments that were passed in, which is going to be the length of the tuple. And the total is just going to be the sum of all the elements inside the tuple. So for that, we can use the built-in Python function called sum, and sum will accept, a tuple or a list. So in this case, it's going to be a tuple, and we're just going to give it args and tell it to calculate the sum. And then what's the average? It's the total divided by the count. So here we would just return total divided by count. Okay, and if we call average with, let's say, 2, 2, 4, 4, I'm doing this on purpose because, as we can see, the average here should be 3, quite easy enough to see. And in fact, that's what we get. The average is 3. Yay, this works. Well, not quite, because now there's a little caveat here. What if I call avg with nothing? Well, we get a 0 division error, which makes sense, right? Because how many numbers are in that tuple? Args, 0. So the count is 0, the total is also 0, and we're trying to divide 0 by 0, which is undefined. We have a 0 division error. So we need to fix that. So let's see. There's a few ways we can fix that. One of the simplest ways is basically to use an if statement and to say if count is greater than 0, well, no, if count is, let's say, equal to 0, we're going to return 0. else we're going to return total divided by count, right? So if the count is 0, we'll return 0, and otherwise we'll calculate total divided by count and return that. So that will certainly work. If we call average with nothing, we get 0 back. If we call average with 2, 2, 4, 4, then we get our average of 3 back. So that's working okay. Now there's a slightly better way of doing it, or maybe not better, but it's an alternative way certainly. And it comes down to eliminating that if statement. You remember the whole thing with short-circuiting and the Booleans? Well, we can write it this way. So let's remove this, and really what we want to do is we don't want this if-else statement. There's a way that we can do that much easier using the short-circuited AND. If you remember that, we're going to return count and total divided by count. If we do that, remember what happens. If count is 0, it's falsy. If it's falsy, false and anything is going to be false. So Python will short-circuit this and return false. Well, it's actually going to return count, right? It's going to return 0, which is what we want. Otherwise, it's going to go ahead and return this total divided by count, right? So that's how the Boolean AND works in Python. Remember, it returns one or the other. So let's try that out. Well, if we try with 2, 2, 4, and 4, again, we get an average of 3. But if we call it with no parameters, we get our value of 0. So we can also do it this way. The last way in which we may want to fix this is to say, no, user, whoever you are calling this function avg, you must specify at least one parameter, and we can force it. We can force it this way. So now I'm just going to take that again, and I'm going to say a comma args. In other words, this function will require at least one positional parameter and then an arbitrary number of additional positional parameters. So now I have that. Now my count is no longer length of args, it's length of args plus 1, because we're requiring at least one positional parameter. And our total is not just the sum of args, it's sum of args plus a. And now we can return total divided by count. Now we don't have to worry about the count being 0 because we are forcing this function to have at least one value. So now we can try it out. We can do 2, 2, 4, 4. That works the same way. And if we try and call average, we will get an error. But it's not a division by 0 error. This is a different kind of error. It's basically saying something, hey, average is missing one required positional argument a, right? So it's saying, no, you can't call it this way. So that's just another way of getting around that problem, or addressing that problem. So however you want to do it kind of depends also on the use case. Sometimes you want to return an average of 0, and sometimes you don't. You actually want to have an error. But it's better than having a 0 division error. That looks like you didn't think of it and you didn't handle the potential exception. The last thing that I want to look at is how we can unpack an interval into positional arguments. So let's look again at another function. Let's call def func1. Let's define it as something with a comma b comma c. We don't need this star c here to illustrate this. And all we're going to do is just print a, print b, and print c. There we go. All right. So we got func1 with 3 parameters, a, b, and c. And let's say we have this list over here. Let's say 10, 20, and 30. And what we want to do is we want to pass those values, 10, 20, 30, to func1. Now, if we try and call func1 and just give it the list, thinking, well, it's a list, it's going to unpack it, right? It's going to unpack it into a, b, and c because that's what it's doing. Well, no, that doesn't work, right? It looks like we're unpacking when we're calling the function with our arguments, but it's not really unpacking. It just works very similarly. What happens here is that the function is saying, no. Python is saying, no, you can't do that. I'm expecting 3 parameters because I could do this, right? It doesn't know that it has to unpack L into A, B, and C. What if I'd meant to call L with, let's say, A and B, right? That will work just fine. And A over here will be the list 10, 20, 30, and then B will be A and C will be B. All right, it's a little confusing. Maybe I should have used something else. Maybe I can use X and Y, right? So A was 10, 20, 30, B is X, and C is Y. So that's what it's doing. So it doesn't know that, if we just pass L, it's going to complain, saying, no, I expected 3 arguments, you only gave me 1, because in fact L is only a single object. So what we can do is we can actually unpack L right here. And when we do that, we now have unpacked L into its 3 elements, and it got thrown into A, B, and C, as we see here. Now, of course, let's say you do this, right? And then we call it. Well, that's going to be a problem because we have 4 elements in the list. We unpacked 4 elements and sent that over to func1, which only accepts 3, right? So that won't work. Now, if you want to be able to do something like that, maybe we do a star args in here, right? And so we'll say, well, we'll do A, B, C and star args, and we'll print args. So we can do that, and I'll add maybe a couple more here just to make it clearer. So we can just throw star args in here, and now when we define our list to be 10, 20, 30, and then 2 extra arguments, it's going to get passed into args. So if we run this, and now run that, sorry, we need to run the function with func1 calling using L. Now, of course, we can't just use L. We have to unpack it first. We indeed get what we expect. A is 10, B is 20, C is 30, and args is the remaining elements that were in that list. So again, just the way you can use unpacking. Now, this is actual iterable unpacking here that is getting passed into then func1. All right, so thanks for watching, and I'll see you in the next video.